Imagine a hidden giant lurking in the shadows of our solar system, influencing the orbits of distant objects without ever revealing itself. This enigmatic presence, known as Planet 9, has eluded direct observation, yet recent statistical evidence suggests it may indeed exist. Why is this significant? Uncovering Planet 9 could revolutionize our understanding of the solar system's dynamics and evolution. Today, we'll explore the latest research that supports the existence of this mysterious planet, examine the debates surrounding its reality, and discuss the future technologies that could finally bring Planet 9 into the light. Join me as we delve into the evidence, the skepticism, and the technological advancements that are painting a new picture of our celestial neighborhood. The quest to verify the existence of Planet 9 has evolved significantly with recent groundbreaking studies, including insights from a comprehensive paper by Konstantin and colleagues. This team has delved deeper into the enigmatic behaviors of trans-Neptunian objects, TNOs, focusing on those with low inclination, Neptune-crossing orbits, which present a new avenue for validating the Planet 9 hypothesis. Utilizing advanced N-body simulations that account for the gravitational effects of all known giant planets, the galactic tide, and nearby stellar passes, the research highlights the peculiar orbital patterns that traditional models without Planet 9 fail to explain. These simulations, underpinned by initial conditions derived from the early migration theories of giant planets and the Sun's formation within a star cluster, reveal that the orbits of these TNOs align closely with predictions that include Planet 9's influence, significantly deviating from the models that do not. The paper also discusses how these findings challenge the standard views on solar system evolution. Traditionally, the solar system was thought to be relatively stable after its initial formation period. However, the observed dynamical structures at its distant edges suggest a more tumultuous history, influenced by a potential ninth planet. This hypothetical planet, with a mass about 10 times that of Earth, is believed to sculpt the trajectories of these distant objects through its substantial gravitational pull, thus potentially explaining the unusual orbital alignment and clustering of these TNOs. The significance of this research extends beyond mere academic interest. Confirming Planet 9's existence would redefine our understanding of the solar system's architecture and dynamics. It would imply that our planetary neighborhood is not only more complex, but also more dynamically active than previously understood. This complexity could influence theories about the Oort cloud, the behavior of comets, and even the potential paths of asteroids that may pose a threat to Earth. Moreover, the study of Planet 9 provides critical data that can help astronomers refine their models of how planets form and evolve, not just within our solar system, but also in extrasolar systems. While the evidence for Planet 9 is compelling to many, it is not without its detractors and alternative theories. Critics argue that the observed orbital anomalies can be attributed to observational bias or other natural celestial mechanics not yet fully understood. For instance, some scientists suggest that the clustering of orbits might result from the collective gravitational effects of numerous smaller, undiscovered objects rather than a single massive planet. One significant alternative to the Planet 9 hypothesis is the idea of a massive trans-Neptunian disk. This theory posits that a dense ring of icy debris beyond Neptune could exert collective gravitational influences similar to those attributed to Planet 9. Such a disk would not only explain the existing data, but also align with observations of other star systems, where similar disks are common. Another intriguing proposition is that modifications to Newtonian gravity, such as those suggested by modified Newtonian dynamics, MOND, might account for the anomalies. MOND has been proposed to explain stellar motion in galaxies without invoking dark matter, and could potentially apply to the dynamics of the outer solar system as well. These debates are crucial for scientific progress. pushing the boundaries of current understanding and technology. Each theory is rigorously tested against observations, with researchers looking for data that can conclusively support or refute the various models. This process ensures that any conclusion drawn is robust, potentially opening new avenues of research or reinforcing the need for more sensitive and comprehensive observational technologies. The future of the Planet 9 hypothesis lies in upcoming observations and technological advancements. The Vera C. Rubin Observatory, set to begin operations soon, is expected to revolutionize our view of the outer solar system. With its wide-field camera capable of capturing the entire available sky every few nights, it will collect unprecedented data on the movements of countless celestial bodies. This observatory will be particularly adept at tracking the faint, distant objects that are crucial to testing the Planet 9 hypothesis. By accurately charting their orbits over time, scientists hope to observe the gravitational influences predicted by the presence of a ninth planet directly. This could either solidify the case for Planet 9 or raise serious doubts about its existence. Additionally, the European Space Agency's Euclid mission, although primarily focused on dark matter and dark energy, will provide valuable data on the positions and movements of galaxies. This data can indirectly inform models of the solar system by improving our understanding of the galactic environment's influence on it. The potential discovery or refutation of Planet 9 is not just a matter of adding another planet to our solar system's roster. It has profound implications for our understanding of planetary science, potentially affecting how we predict and mitigate the paths of near-Earth objects. It also offers a bridge to understanding planetary systems around other stars, enhancing our search for exoplanets and the conditions that might support life. Regardless of the outcome, the quest for Planet 9 will undoubtedly expand our knowledge of the cosmos, making it an exciting time for astronomy. Thank you for joining me on this intriguing exploration of Planet 9. Whether or not this elusive planet exists, the quest for understanding continues to push the boundaries of space exploration and science. As we look forward to the revelations from new technology and further studies, one thing remains clear: the mysteries of our solar system are far from being fully uncovered. Stay tuned as we continue to unravel the cosmic puzzles that lie beyond the familiar planets. What's next? The upcoming Vera C. Rubin Observatory could finally spot this elusive planet or prove it's just a ghost in the cosmos. Either way, we're on the brink of new discoveries that could reshape our cosmic view. Stay tuned and let's uncover the mysteries of our solar system together. Please don't forget to like, subscribe, and click the notification bell for more updates as we continue to unlock the mysteries of the universe together.